Welcome back to Talk Tensors, everyone. Today we're going to be taking a deep dive into a paper that's been making some serious waves in the world of zero-shot learning with multimodal knowledge graphs.
It's called a zero-shot learning method based on large language models for multimodal knowledge graph embedding. And it proposes this really intriguing new framework called ZSLM.
Okay, so before we get too far, could you give us a little bit of a breakdown of what ZSLM is and why it's such a big deal?
Sure. So ZSLM essentially leverages the power of LLMs, these large language models we've been hearing so much about, to tackle the problem of zero-shot learning within multimodal knowledge graphs.
And for those of us who might need a quick refresher, what exactly is zero-shot learning again?
Good point. It's basically the ability of a model to understand and classify categories it hasn't explicitly been trained on. Like, imagine being able to identify a pangolin even though you've never seen one before, just by knowing its characteristics and how it relates to other animals.
So instead of training an AI on every single type of animal out there, we can now use LLMs to help it make those connections on the fly. That sounds like a huge leap forward.
It really is. Current methods for zero-shot learning in MMKGs often struggle to effectively transfer information about these unseen categories, which leads to less than stellar accuracy.
So how does ZSLM actually address this problem? How does it use LLMs to improve zero-shot learning?
Well, ZSLM utilizes textual data like descriptions of unseen categories as prompts for the LLM. So let's stick with our pangolin example. We could give the LLM a description of a pangolin like scaly anteater.
Interesting. So the LLM then uses this description to kind of fill in the gaps in its knowledge about pangolins, even though it's never actually seen one?
Exactly.
Huh.
The LLM helps generate what are called auxiliary features for the unseen categories. These features provide additional information that helps with that semantic information transfer, making it easier for the model to understand and classify new things.
So the LLM is kind of like a researcher doing a super fast literature review on pangolins, gathering all the relevant information and presenting it to the model.
That's a great way to put it. And it's not just LLMs doing all the work. ZSLM uses a combination of techniques to achieve this.
Okay, I was just going to ask about that.
Yeah.
The paper mentions convolutional neural networks, CNNs, knowledge distillation, and graph convolutional networks, GCNs. It sounds like a pretty complex system.
It is, but each component plays a crucial role. CNNs are like the eyes of the AI system, helping it process and understand the image data in the knowledge graph.
Right, because a description of a pangolin is helpful, but being able to analyze an image of one takes that understanding to another level.
Precisely. Then you have knowledge distillation, which is kind of like an apprenticeship for AI.
An apprenticeship. What do you mean by that?
So you have a teacher model that's been trained on a bunch of seen categories, and then you have a student model that's trying to learn about the unseen categories. The teacher model essentially guides the student model, helping it learn more effectively.
So it's like a senior doctor mentoring a new intern, sharing their expertise and helping them make sense of new cases.
Exactly. And then finally, you have the GCNs. These are the masters of relationships. They analyze the connections within the multimodal knowledge graph, helping the model understand how everything fits together.
So if the CNNs are the eyes and the knowledge distillation is the mentorship, the GCNs are like the brain putting all the pieces together.
A perfect analogy. You've got it. And by combining all of these techniques, ZSLM is able to achieve some pretty impressive results in zero-shot learning.
That's what I'm really curious about. How well did this new framework actually perform in their tests?
Yeah.
Did it live up to the hype?
Well, they tested ZSLM on 3 prominent datasets: ImageNet, AWA2, and APY. These are pretty much the gold standard for image recognition and zero-shot learning.
So no pressure for ZSLM then. So how did it do?
It actually exceeded expectations.
Right.
Across all 3 datasets, ZSLM consistently outperformed existing zero-shot learning models. It was really quite remarkable.
Wow. So it wasn't just a fluke. It consistently showed improvements across the board.
Mm-hmm.
Okay, so we know it works. But what kind of performance improvements are we talking about? Were they significant?
They were definitely significant. Let's take the APY dataset as an example. This one focuses on object recognition, and ZSLM achieved a top 1 accuracy of 58.4% for unseen categories. Now, to put that into perspective, some of the previous best methods were only achieving around 26% accuracy.
Hold on, you're saying GSLM more than doubled the accuracy on that dataset? That's incredible.
Mm-hmm.
It really highlights the potential of this approach.
It really does. And what's even more exciting is that it wasn't limited to just one specific data set or task. It showed consistent improvements across all the data sets they tested on.
That's what makes me really optimistic about the potential real-world applications of this technology. But before we dive into that, I think it would be helpful to take a step back and understand the historical context that led to this point.
Absolutely. This research didn't just appear out of thin air. It's built upon decades of work in knowledge graphs and zero-shot learning. So let's rewind a bit and trace the path that led us to this breakthrough.
Okay, I'm ready for a little AI history lesson. Where should we start?
Well, let's go all the way back to the 1980s with a project called WordNet. This was one of the first attempts to create a structured representation of knowledge, what we now call a knowledge graph.
So it's like a family tree for words, showing how they're related to each other.
Exactly. WordNet was mainly focused on textual information, but it laid the foundation for what would become a much richer and more complex field of research.
And as the digital world evolved, so too did knowledge graphs, right? They had to adapt to the explosion of multimedia content.
You got it. That's where multimodal knowledge graphs, or MMKGs, came in. These knowledge graphs incorporate images, videos, audio, all sorts of different data modalities.
It's like going from a black and white photo to a full-color immersive experience.
Precisely. And this shift towards MMKGs was crucial for enabling more sophisticated zero-shot learning techniques like ZSLM.
Okay, so we have these incredibly rich knowledge graphs. But how did zero-shot learning evolve alongside them? How did we go from those early attempts to what we have today with ZSLM?
Well, those early approaches to zero-shot learning were often based on using attributes or textual descriptions to make inferences about unseen categories. For example, imagine trying to teach an AI model to recognize a zebra without ever showing it a picture of one.
You could give it descriptions like black and white stripes, herbivore, lives in Africa, things like that.
Exactly. The model could then use these attributes to connect a zebra to other animals it already knew, even if it had never seen a zebra specifically.
It's like a game of 20 questions where you try to narrow down the possibilities by asking about key characteristics.
It's a great way to think about it. However, these early methods often struggled when it came to more complex relationships or subtle distinctions between categories.
It's like trying to understand a whole person based solely on their height and hair color. You're missing a lot of nuance.
Precisely, and that's where deep learning came in and changed the game.
Right. Deep learning models, with their ability to learn complex patterns from massive data sets, revolutionized the field of AI.
Absolutely. It was like upgrading from a bicycle to a rocket ship. It allowed AI models to analyze the underlying structure of data in ways that were previously impossible.
So instead of just relying on basic attributes, deep learning models could now learn to recognize those subtle features and connections that were invisible before.
Exactly. And that brings us to the era of large language models, or LLMs, which have taken zero-shot learning to another level entirely.
LLMs are like those language wizards who can understand and generate human-quality text in a way that was previously unimaginable.
They really are. And by combining the power of LLMs with the richness of multimodal knowledge graphs, we're starting to see some truly remarkable advancements in zero-shot learning. And that's exactly what this research paper is all about.
So this paper is really at the forefront of this exciting convergence of knowledge graphs, deep learning, and large language models.
It is. And the results they achieve with ZSLM are a testament to the incredible potential of this approach.
And it's not just about theoretical advancements. The potential real-world applications of this technology are vast and could impact many aspects of our lives.
Absolutely. But before we get into all that, I think it's time to take a deeper dive into the history of knowledge graphs and zero-shot learning.
Yeah, let's rewind the clock and trace the evolution of these fields from those early beginnings to the groundbreaking research we're discussing today.
Sounds like a plan. Let's embark on this historical journey together.
I'm ready when you are.
Okay, so we're back, ready to delve into the history of knowledge graphs and zero-shot learning.
Yeah, let's time travel back to the early days and trace the path that led us to this cutting-edge research with ZSLM.
All right, so picture this. It's the 1980s, and a project called WordNet emerges. It was a pretty big deal back then.
WordNet, okay. I vaguely remember hearing about it in my AI history class. What was so special about it?
Well, it was one of the first attempts to create what we now call a knowledge graph. Basically, a way to represent knowledge in a structured format, kind of like a map of concepts and their relationships.
So instead of just having a jumbled mess of data, we now have this interconnected web of information that AI can actually understand and navigate.
Exactly. WordNet was mainly focused on textual information, but it laid the groundwork for what would become a much richer and more complex field of research.
And as the internet exploded with multimedia content, knowledge graphs had to evolve too, right?
Oh, absolutely. They had to keep up with the times. So that's where multimodal knowledge graphs, or MMKGs, entered the picture.
MMKGs. Okay, so these are the knowledge graphs that can handle images, videos, audio, all sorts of different data modalities.
You got it. It's like going from a basic text-based encyclopedia to a multimedia extravaganza with pictures, videos, sound effects, the whole shebang.
I can see how that would be crucial for AI trying to understand the world. It's like giving them access to all of our senses, not just language.
Exactly. And this shift towards MMKGs was essential for enabling more sophisticated zero-shot learning techniques like the ZSLM we're talking about.
Okay, that makes sense. So we've got these increasingly complex knowledge graphs, but what about zero-shot learning itself? How did those early approaches evolve into what we have today?
So those early attempts at zero-shot learning often relied on using attributes or textual descriptions to try and make inferences about unseen categories. Think about it like this. Imagine you're trying to teach an AI model what a zebra looks like without ever actually showing it a picture of a zebra.
So you give it clues like has black and white stripes, runs fast, found in Africa, that kind of thing.
Precisely. The model could then use those attributes to try and connect a zebra to other animals it already knew, even if it had never specifically seen a zebra before.
It's like those logic puzzles where you have to figure out who's who based on a few clues.
Exactly. But as you can imagine, those early methods had their limitations. They often struggled with more complex relationships, or when those subtle distinctions between categories weren't so obvious.
It's like trying to describe a complex emotion like love using only a handful of words. You're going to miss a lot of the nuance.
Right. And that's where the deep learning revolution came in and really shook things up.
Ah, yes. Deep learning with its ability to learn from massive amounts of data and extract those intricate patterns.
Exactly. Deep learning was like giving those AI models a supercharged brain boost. It allowed them to go beyond those simple attribute-based approaches and really start to understand the underlying structure of the data.
So instead of just looking at a zebra's stripes, they can now analyze its gait, its social interactions, its habitat, all sorts of complex factors.
Exactly. And that brings us to the era of large language models, or LLMs, which have taken zero-shot learning to a whole new level.
LLMs, those models that can generate hue and quality text, translate languages, write different kinds of creative content. It's pretty mind-blowing.
It really is. And when you combine the power of LLMs with the richness of those multimodal knowledge graphs, you start to see some really amazing advancements in zero-shot learning.
And that's exactly what this research paper with ZSLM is all about. It's showcasing the power of this convergence between knowledge graphs, deep learning, and LLMs.
Precisely. It's like taking the best of all worlds and combining them into a super-powered AI system.
So we've come a long way from those early days of WordNet and basic attribute-based zero-shot learning. It's been quite a journey.
It has, and it's not over yet. The field of AI is constantly evolving, and who knows what incredible breakthroughs we'll see in the years to come.
That's what makes it so exciting. It feels like we're on the cusp of a new era of AI where these systems are becoming more and more capable of understanding and interacting with the world in ways that were once unimaginable.
I completely agree. It's a really fascinating time to be involved in this field.
Well, speaking of fascinating, I'm really curious to hear your novel notions for this episode. What kind of big ideas has this research sparked for you?
All right, so this paper got me thinking about the limits of prediction. We've been talking about using AI to identify things it's never seen before, but what if we could take that a step further? What if we could use a similar approach to actually predict the emergence of entirely new categories within a knowledge graph, even before we have any data about those categories?
Whoa, hold on. You're talking about predicting the future of knowledge itself. That sounds like something straight out of science fiction.
Haha. I know it sounds a bit far-fetched, but hear me out. What if we could use LLMs to analyze those trends and patterns within the existing data of an MMKG? It's like those stock market analysts who try to predict future market movements based on historical data.
So we'd be looking for those subtle signals within the knowledge graph that suggest something new is about to emerge, something that doesn't even have a name yet.
Exactly. It's like trying to predict the invention of the smartphone before anyone had even conceived of it. We'd be analyzing trends in mobile phones, internet usage, and user behavior to see if those patterns hinted at the convergence of these technologies into something entirely new.
That's a pretty mind-boggling concept, but I can see the potential value in it. Imagine being able to anticipate emerging trends in various fields. It would be like having a crystal ball for knowledge.
Precisely. We could potentially forecast new diseases, predict the rise of social movements, or even anticipate technological breakthroughs that could reshape our world.
Okay, now you're really blowing my mind. But let's be realistic for a moment. How would we even go about building such a system? What kind of data and methods would we need?
Well, that's where it gets really interesting. We'd need to develop new techniques for analyzing the evolution of knowledge graphs over time, looking for those telltale signs of change and emergence. We'd essentially be studying the dynamics of knowledge itself, tracking how concepts and relationships evolve and give birth to new ones.
It's like becoming historians of the future, charting the course of human knowledge as it unfolds.
Exactly. And LLMs would play a crucial role in this. They could help us to understand the meaning and context of those evolving patterns, identifying the subtle shifts that signal the birth of something entirely new.
So we'd be teaching AI to not only understand what we know, but to anticipate what we're about to know. That's pretty amazing.
It is, but of course this is all very speculative at this point. It's a novel notion after all. But it's the kind of big, ambitious idea that pushes the boundaries of what we think is possible and drives scientific progress.
Well, it's certainly given me a lot to think about. And even if it remains theoretical for now, it really highlights the incredible potential of this research in the future of AI.
I completely agree. And as researchers continue to explore these areas, I have no doubt that we'll see even more groundbreaking discoveries in the years to come.
This has been an incredible deep dive so far. We've explored zero-shot learning, delved into the history of knowledge graphs and LLMs, and even ventured into the realm of predicting the future of knowledge. I feel like my brain is overflowing.
Haha, mine too. It's always a pleasure to discuss these fascinating topics with you. Okay, so let's dive into those novel notions you mentioned.
Yeah, you really got my wheels turning with that idea of predicting the emergence of entirely new categories within a knowledge graph before we even have data about them. That's some next-level AI stuff.
I know, right? It's a pretty wild thought, but I think it's worth exploring. So imagine this. We're using LLMs to analyze those trends and patterns within the existing data of an MMKG. Like those stock market analysts who try to predict market movements based on historical data. We'd be looking for those subtle signals that suggest something new is on the horizon.
Okay, so we're basically playing AI fortune teller, trying to decipher the whispers of change within the knowledge graph to anticipate those groundbreaking innovations that haven't even been conceived of yet.
Precisely. Like imagine trying to predict the invention of the internet before it happened. We'd be analyzing the trends in communication technologies, data transmission, and human interaction to see if those patterns pointed towards the emergence of a global, interconnected network.
Wow, that's a heady concept.
Yeah.
But I can see how it could be incredibly valuable in so many fields. Predicting emerging diseases, anticipating shifts in consumer behavior, forecasting technological breakthroughs. It's like having a sneak peek into the future of knowledge.
Exactly. It would be like having a crystal ball for innovation. But of course, this is all very speculative at this point. It's a novel notion after all.
Right, but it's those kinds of big, out there ideas that push the boundaries of scientific inquiry. Who knows, maybe one day we'll have AI systems that can not only understand what we know, but also predict what we're about to discover.
It's definitely a fascinating possibility, and even if it remains theoretical for now, it highlights the incredible potential of this research and the future of AI.
Absolutely. This entire deep dive has been mind-expanding. From exploring the intricacies of zero-shot learning to delving into the history of knowledge graphs and LLMs, and now venturing into the realm of predicting the future of knowledge. I feel like I've just upgraded my mental operating system.
Me too. It's always a pleasure to discuss these cutting-edge topics with you.
Well, on that note, I think it's time to wrap up this episode of Talk Tensors. We've covered a lot of ground today, and I hope our listeners are as excited about the future of AI as we are.
I second that. It's an incredible time to be following this field, and I can't wait to see what breakthroughs the future holds.
And to our listeners, thank you for joining us on this journey. If you're interested in learning more about zero-shot learning, multimodal knowledge graphs, or any of the other topics we discussed today, be sure to check out the show notes for links to the research paper and other resources.
And as always, feel free to reach out to us on social media. We love hearing from you and engaging in thought-provoking discussions about the world of AI.
Until next time, keep those neurons firing and stay curious.